Okay, for the first question, they want you to draw a tree diagram and list the sample space for the given situation. Sample space was one of our vocabulary words. That's where you're listing all of the possible outcomes. So, draw your tree diagram and list the sample space. Okay, so we have 4 numbers to choose from, so I'm going to branch out 4 ways. We can choose a 1, a 2, or a 3, or a 4. If you chose a 1, you have 3 color choices that you could choose from. You can abbreviate and do B for black, W for white, G for gray. So on each one of your numbers, you're adding these 3 colors off of it. How many total outcomes do we have? 12. And the sample space wants us to list those outcomes. So our outcomes would be 1 black, 1 white, 1 gray, 2 black, 2 white, 2 gray, 3 black, 3 white, 3 gray, and 4 black, 4 white, 4 gray. Okay, for the next question, they give you the outcome and the frequency. Remember, the frequency is the number of times it happens. So you are using this chart to find your probabilities. You have 3 sticks. Each stick has 1 red side and 1 blue side. You throw the sticks 10 times and record the results. Use the table to find the experimental probability of the event. If we look at the first one, tossing 3 red, the outcome 3 red happened how many times? 0. So it'd be 0 out of 10 because we threw the 6 10 times.
Do we have to draw the table?
So for tossing 3 blues, how many times did 3 blues come up? 1 out of how many times? 10. Yep. Okay, so for number 4, tossing 2 blue and 1 red, how many times did that occur? 3 out of how many total? 10. And for tossing 2 red and 1 blue, how many times did that occur? 6 out of 10, which can be simplified to 3/5. Okay, for our next question, they want you to use the bar graph to find the experimental probability of the event. You spun the spinner 50 times. Write the probability as a percent, decimal, and a fraction in simplest form. So this time you need to make sure your answer is expressed in all 3. This chart tells you how many times each number was spun. So if we look at it, number 1 was spun how many times? 7. Number 2 was spun 7. Number 3, 4 was 7. 5 was 6 times. 6 was 9. 7 is 7. And 8, 4 times. So go ahead and answer these 3 questions. Okay, so for spinning a 5, how many times did we spin a 5? 6 out of 50. Can we simplify this fraction?
Yes.
3/25. We can simplify by dividing both by 2. How would we write this as a decimal? 0.12. We divide top divided by bottom, and we change that to a percent and get 12%. For the next one, spinning a 1 or a 7. A 1 we landed on 7 times, and a 7 we landed on 7 times. 7 plus 7 is 14, so we have 14 out of 50. Can we simplify this fraction? We could divide by 2 to get 7 out of 25. How would we write this as a decimal? 0.28, and as a percent it would be 28%. For the last one, spinning an even number. Every time we need an even number, we need to add those up. So for 2, that was 7 times, 4 was 7 times, 6 was 9 times, and 8 was 4 times. When you add all 4 of these up, what did you get? 27. So we have 27 out of 50. Can this be simplified? No. How do we write it as 0.54, and as a percent would be 54%. Okay, so for numbers 9 and 10, they want you to tell whether the events are independent or dependent. The first one, or number 9, is your teacher chooses one student to lead a group and then chooses another student to lead a different group. Remember, independent is where one does not affect the other. Dependent, one does affect the other. Your second probability changes. So, what do you think number 9 would be? Yeah, it's dependent, because if I choose someone for a group, are they part of the running to be the leader of the next group? No. So the second probability changes because you're taking that person out, so there's one less person to choose from. And for number 10, you choose a marble from a bag with replacement. Your first marble is green, your second marble is purple. What type of an event?
Independent.
Independent. They can happen on their own. One does not affect the other. We're putting the marble back so we could still choose it on the next one. Okay, for the next 3 questions, a spinner has 4 equal sections numbered 1, 2, 3, and 4. You spin it twice. Find the probability of the following events. Is spinning the spinner twice independent or dependent? Independent. Whatever we get on the first one does not affect what we land on the second time we spin it. So we want to find the probability of each event and multiply. So we want the probability of 1 times the probability of 4. What is the probability that we land on a 1? Yeah. 1 out of 4. And what's the probability that we land on a 4? 1 out of 4. We multiply these. 1 times 1 gives us 1. 4 times 4 gives us 16. So we have 1/16. Okay, for number 12, spinning a 3 and then spinning an even number. How many 3s do we have on our board? 1, so it's 1 out of 4. And how many even numbers do we have? 2 out of 4. We multiply. 1 times 2 gives us 2. 4 times 4 is 16. And we can simplify this to 1/8. For number 13, spinning an even and then spinning an odd. How many even numbers? 2 out of 4. And how many odd numbers? 2 out of 4. We multiply. 2 times 2 gives us 4. 4 times 4 gives us 16, and it simplifies to 1/4. You have a spinner to the left. It has 10 sections numbered 1 through 10. You spin the spinner, list the favorable outcomes of the event. You are not finding the probability. So for 14, if you wanted to spin an even number, what numbers would you want to land on?
4, 6, 8, 10.
So those are your favorable outcomes. You're not finding any probabilities. You're just listing the favorable outcomes. For divisible, what does divisible mean? Yeah, you can divide by that number evenly. Okay, what would be our favorable outcomes for divisible by 3? 3, 6, 9. Those three numbers can be divided by 3 evenly. And for spinning a number less than 5, 1, 2, 3, and 4. Can we include 5 in this? No, it's not less than 5. We have, you randomly choose the letter blocks without replacing the first block. You choose the second block. Find the probability of choosing the first block and then the second block. So, do we have independent or dependent events? Dependent. Whatever we choose the first time changes our probability on the second event. So, probability of M and M. How many M's do we have? 2 out of 8. If we take out an M, if you want, you can cross it off. If you take out an M, how many M's are left? 1 out of 7, because we took out this tile, so we have 1 less to choose from, so 1 out of 7. Multiply your numerators. 2 times 1 is 2. 8 times 7 is 56. What does this simplify to? 128. When you switch to the next question, we're starting fresh with all 8 tiles. And the first one, or the next one is T and not A. So what would be our probability of choosing T? 2 out of 8. If we took away a T, so if I cross out a T, to choose from, how many tiles do we have left? 7. Out of those 7, how many are not A? 5 of them. And multiply. 2 times 5 is 10. 8 times 7. And this simplifies to 5/28. And then when you start the next question, we're starting with all 8 tiles again. The probability of A and H. Okay, so for 19, what's the probability that we choose A? 2 out of 8. If I take out an A, how many total tiles do we have left? 7. Out of those 7, how many are H's? 2. So we get 4 over 56, which simplifies to 1/14. Okay, the next question. You have a jar of marbles. The jar contains 3 red marbles, 11 blue marbles, and 7 green marbles, and 6 yellow marbles. Determine your theoretical probability of the event and write your answer as a fraction in simplest form. So this is basic probability, the number of favorable outcomes over your total. Okay, so for choosing a green marble, how many green marbles do we have? 7 out of how many total? 27. So we have 7 out of 27. Can this be simplified? No, so we're all set. Choosing or not choosing a blue, we want all the marbles that are not blue. You could add up your red, your yellow, and your green, or you could subtract the amount of blue. So we have 27 total. Out of those 27, 11 of them are blue. How many are not blue? 16. Can this be simplified? No, so we're in simplest form. Next one, choosing a yellow or a red marble. How many yellows do we have? 6. How many reds? 3. 6 plus 3 gives us 9, and we have 9 out of 27. Can this be simplified? Yeah, if you divide by 9, we get 1/3. Okay, for 23, we are making predictions. I'm going to do this one with you, and then I'm going to have you try the next one on your own. Okay, so in a board game, you have 84 lettered tiles. You randomly pick these tiles shown. How many of the 84 lettered tiles would you expect to be vowels? So remember, we write our probability as a fraction and then our estimate as a fraction, and we set them equal to each other. If we look at the tiles, how many of our tiles that we chose are vowels? 2. Out of how many total tiles did we draw? 7. And then we have 84 total. Where would that go in the numerator or the denominator? Denominator, and we're not sure how many vowels you'd expect. So we have a proportion. You have to cross multiply and solve for x. 7 times x gives us 7x, and 2 times 84 gives us 168. What do we have to do to both sides? Divide by 7, and we get that x equals 24. So in the entire board game of the 84 letters, we'd expect 24 of them to be vowels.
Why do you have to divide by 7?
To get x by itself, because we have 7 times x. If you do the opposite, divide by 7 to get x by itself. Okay, for the next question, you check 15 batteries. 6 of the batteries do not have a charge. Out of the next 90 batteries you check, how many would you expect to not have a charge? So you're going to set it up the same way. Write your probability out, set it equal to your fraction, fill in what you know, cross multiply to solve for your unknown. Okay, so if you look at our experimental probability, how many of the batteries do not have a charge? 6 out of our total of 15. We want to find out how many out of 90 wouldn't have a charge. Does 90 go in the numerator or the denominator? Denominator, and we put x in our numerator. When you cross multiply, 15 times x gives us, and we set that equal to 6 times 90, which is 540. What do we have to do to both sides? Divide by 15, and we get that x equals 36. So we would expect 36 of the batteries to not have a charge.
What I just did is I figured out that 15 times 6 equals 90.
Yeah, so that works. So if you had 6 over 15 equals x over 90, you can evenly go from 15 to 90 by multiplying by 6. So if you do the same to your numerator, 6 times 6, it gives you x to equal 36. Either way works, as long as you show your work.